Hello, today we're going to recap something we did last year, which you'll all be familiar with, but it is worth highlighting because I think there are some common mistakes and misconceptions here. So today I'm going to talk about linear sequences. Now, what I mean by linear, also called arithmetic sequences, these are sequences of numbers that always go up by the same amount or go down by the same amount every time. There are other types of sequences like geometric sequences or quadratic sequences or Fibonacci style sequences, which you probably are not going to encounter, and most of the time you're going to be looking at linear or also called arithmetic sequences. So sequences that go up by the same amount every time or go down by the same amount every time. So for instance here, I've got one linear or arithmetic sequence, 4, 7, 10, 13, 16. It's linear because it always goes up by the same amount, and that amount we can all see is 3. So from here to there is plus 3, here to there plus 3, here to there plus 3, and so on and so on. Now, you probably will be asked to find the nth term. The nth term of the sequence. Well, that means find the algebraic expression that generates that sequence. And it's a fairly straightforward process. That sequence, 4, 7, 10, 13, 16, goes up in threes. Now, what else do we know goes up in threes? And think back to year 2 or 3 or whatever it was. It's the 3 times table. So, I can write the 3 times table here. 3, 6, 9, 12, 15, and so on and so on. So, because the sequence goes up in threes, the nth term of this sequence is going to be 3n. 3n because it's the 3 times table. When n is 1, 1 times 3 is 3. When n is 2, the second term, 2 times 3 is 6. So this generates the 3 times table here. 3n is the 3 times table. But that's not quite that. But you can spot, you can see that to go from here to there, I'm adding 1. From here to there, I'm adding 1. Here to there, I'm adding 1. And I'm adding 1 to every term. So the nth term is 3n plus 1. That is your answer for the exam. Here, I've got a different sequence. We can see that the common difference every time is take away 4. This time the sequence is going down in 4s, but it doesn't matter. It's exactly the same thing. We're going to write the minus 4 times table here. So minus 4, minus 8, minus 12, minus 16, etc., etc. So, because the sequence is going down in 4s, the nth term is going to be minus 4n, and then it's exactly the same thing. How do I go from here to there? Well, I need to add 29, because from minus 4 to 25, I need to add 29. From minus 8 to 21, I am also adding 29, and from minus 12 to 17, I am also adding 29. So the nth term is going to be minus 4n plus 29. Sometimes I may have to take away instead of add, but it's the same thing. So that is my answer for the exam. Now, something else they may ask you. Let's go back to this example here. 4, 7, 10, 13. Okay, they may ask you, is the number, so is 252 in the sequence? Is 252 in this sequence? The way to really get the full marks, the best way to approach this question is to solve this little equation here. 3n plus 1 equals 252. So basically, is there a number that if I multiply times 3 and add 1 gives me 252? If there is a number, then the number will be in the sequence. If there is no number, then 252 will not be in the sequence. So I just got to solve this equation here. So 3n equals 251, n equals 251 divided by 3. If the answer is an integer, then yes, it will be in the sequence. If the answer is not an integer, then it will not be in the sequence. So, I haven't got a calculator with me, but 251 divided by 3 is 83 remainder, so 83 point something. 252 is not in the sequence because n is not an integer solution. And that's it for sequences. That's pretty much all you need to know about sequences. Sometimes, instead of the number sequence, they may give you a picture pattern, and you have to spot the sequence from the picture pattern. But, you know, I am pretty certain you can count bars or circles in a picture pattern. But anyway, this was a bit of a recap. Copy the examples down, pause, rewatch, rewind, whatever you need, and let's have a look at this, right?